Welcome to my channel. I'm Zhan Xu. Let's look at the problem 7 in chapter 28. Chapter 28 is about the sources of magnetic fields. So there you can see we have two long thin parallel wires, right? The wire 1 and wire 2. And then we have another point is called P. We need to determine the magnetic field vectors at this point. So now let's see what quantity is given. The current on these two wires is given, and the distance from wire to the P point is given R1 and R2. The distance between these two wires is given as D, right? And then the constant mu naught is given. So we can consider this is theta naught, theta 1, this is theta 2. Now we need to find the magnetic fields at the point P, right? As we can consider, this magnetic field is a vector, agree? So we have the vector B1 by the wire 1. So how can we do that? We can say this is dot. Dot means out, right? Take out your right hand, use right hand rules. You can see the four fingers out, right? And then roll to L1, roll to L1. So your four fingers out, roll to L1, so you can determine the magnetic field B1 pointing to this direction. As we can see, this is a 90 degree. Do you agree? Yes. And then we can consider the theta 1 plus this angle plus this green angle is 90 degree, right? And then this green angle plus this part is another 90 degree. Agree? This green angle, let me mark it there. This green angle plus this green one is another 90 degree, right? So that means this blue one equal to theta 1, right? No problem. So we write it theta 1. Then we look at the wire 2, right? Take your right hand, do the right hand rules. The dot means out. Then out rotate to R2. So we find B2 pointing to this direction. Agree? Yes. Now we can see how can we determine its direction. We can see this is theta 2, right? The theta 2 plus the yellow one is 90 degree. Agree? And then let me change the color. This red angle plus this yellow one 90 degree. So make the red one equal to theta 2, right? So we can write it as theta 1, theta 2, right? Now we can do next step. We see, now we can determine the magnitude for the B1 and B2. It's easy. B1 is just the magnitude due to a straight wire, right? Mu naught times I 2 pi R1, the distance from the wire R1. And then B2 as mu naught I divided by 2 pi R2. R2 is given, right? The distance between the P point and the wire. Now we can see this is two vectors. We need to find the addition for two vectors. We can project them in the x component and the y component. Agree? So at x component, you can see this is B1 times cosine theta 1, right? Minus B2 times cosine theta 2, right? Yes. And then in the y component, we can see it's B1 sine theta plus the B2 sine theta 2, right? So you get it there. Now you can see B1, B2 magnitude is get. So how can you calculate Bx, By? Looks like you must know theta 1, theta 2, right? How can you do that? You can see you have this triangle. The straight length is given R1, R2, D. Can you find theta 1, theta 2? Yes. This is just use the law of cosine, right? So look at the law of cosine. We look at theta 1. So very easily we can see the theta 1 faces this side. So R2 square equal to R1 square plus D R1 square plus D square minus 2R1D cosine theta 1. This is a law of cosine theta. Similarly, we can get this one from the theta 2, right? theta 2, we can get it there. So from, you can say in these two equations, R1, R2, D is given, so you can get the theta 1 and theta 2 very easily, right? So next step, we just need to calculate theta 1, theta 2 and put it inside. We can get B as B1, then we are done, right? So now you can say B1, B2, we write it there, and then how you calculate the theta 1, theta 2, so you get the equation at there, theta 1, theta 2, you get these two angles, right? Next one, you input the B1, B2, theta 1, theta 2 in these two equations. Then you can see you get the number there. Now we know this is a vector B, right? It has two components, X and Y, so you can get the addition. The magnitude for B and the theta angle theta for B at there. Thank you.